disasters I will be covering are the flash floods that occurred in Missouri and Kentucky this past July. Historic rainfall due to a stalled frontal system and heavy moisture from the Gulf caused flash flooding events in parts of Missouri on July 26th and in Kentucky on July 28th. Several places in St. Louis, Missouri saw more rainfall than ever before at rates of more than 2 inches per hour. According to the NOAA, the St. Louis Lambert International Airport recorded a one-day total rainfall of 8.6 inches, making it the highest single-day rainfall measurement in the St. Louis area since record-keeping began in 1874. The same stalled frontal system caused historic flash flooding in parts of Kentucky as well. Rainfall rates exceeded 4 inches per hour, and radar estimates show that 5 to 10 inches of rain fell across a multi-county region from Laurel County eastward to Knott County on July 28th. Combined, these two catastrophic flooding events cost $1.2 billion and 42 lives were lost.
Deadly floodwaters tore eastern Kentucky apart. Some areas so isolated, even this Black Hawk helicopter couldn't easily reach this community, where a main road was obliterated.
You can see there's a home down there tucked between the hills, and we're told that the roadway has been completely cut off. They need food and water, and this helicopter is going to bring it to them.
The deadly once-in-a-thousand-year floods destroyed bridges, ripped down power lines, and snapped homes like toothpicks. Overhead, it's clear much of the water has receded, but the desperate searches continue.
I don't think we still know how big the situation is. It could go on for a couple weeks. It could go on for a month.
At least 37 killed, the death toll likely to climb. Among the lives lost, 4 children, all siblings. The governor said they'll be finding bodies for weeks.
We aren't going anywhere.
The National Guard already rescuing more than 1,000 people by air, including an 83-year-old woman and her family trapped in their attic.
24 different billion-dollar floods have occurred between 2002 and 2022. The number of billion-dollar floods have fluctuated over the last 20 years, with some years having more than others. Scientists predict that the number of these disasters will increase as the earth warms and sea levels rise. In total, flooding has caused 315 lives and $89.8 billion since 2002.
Weather and climate-related disasters have cost the U.S. nearly $2 trillion over the past 40 years. According to a recent report from Stanford, about $200 billion of that damage has been caused by floods, and more than one-third is a result of precipitation becoming increasingly more intense over the years.
Not all flash floods begin the same way. Sometimes slow-moving tropical storms unleash downpours for days over a large area. In other instances, single stalled thunderstorms unload all of their water on one unfortunate location. The flooding in Missouri and Kentucky was caused by a parade of thunderstorms passing over the same areas like train cars along a track. Higher July temperatures in Missouri and Kentucky combined with tropical storm moisture led to a stalled frontal system that caused continuous thunderstorms. Overall, increased levels of carbon dioxide in the atmosphere has caused an increase in rainfall in these states due to rising temperatures. Rising global temperatures also cause ice caps to melt, which has led to rising sea levels, resulting in more intense tropical storms and additional flooding. The terrain and surface area of Kentucky and Missouri also contributed to these flash floods. According to our textbook, mountainous areas are susceptible to flash floods because steep slopes can quickly funnel runoff into narrow canyons. Urban areas such as St. Louis are also susceptible to flooding because a high percentage of the surface area is composed of impervious surfaces such as roofs, streets, and parking lots, where runoff is very rapid. So what can be done to prepare for floods in the future? There are a few physical structural options for humans to control flooding in their areas, such as artificial levees, flood control dams, and channelization. However, these methods can be expensive and dangerous for those who live on a floodplain. They do not completely solve the issue of flooding, let alone flash flooding. According to our textbooks, many scientists and engineers advocate a non-structural approach to flood control. They suggest that an alternative to artificial levees, dams, and channelization is sound floodplain management. By identifying high-risk areas, appropriate zoning regulations can be implemented to minimize development and promote more appropriate land use. These are the sources that I used for my presentation.